This is Hadoop's 10-year birthday. Hadoop's a 10-year-old. I'm Doug Cutting. I'm a software developer. I'm a dad and a husband and a cyclist. I was born here in the Napa Valley, lived here most of my life, and grew up right here on this lot. 96, I think we got married, so 19 years. At its simplest, Hadoop is a way to take a bunch of computers and make them appear as one computer to software. There's two things that people mean by Hadoop. Apache Hadoop, which is a project which has some defined functionalities, and then people use it more generally to talk about this whole set of technologies that are built around it. My son had this yellow elephant toy, and we would hear him calling it Hadoop. And then at one point I realized, wait a minute, that would be an awesome software project name. I'm pretty tickled by all the uses I hear about. We're seeing people save lives. Hospitals are reducing their sepsis rate measurably. Neonatal ICUs, improving the care of premature babies. My dad found his wife through an online dating system that used Hadoop. To him, that's the greatest application of Hadoop ever. In the early days, it was primarily a guy named Mike Caffarella and I who were working on this stuff. I certainly didn't imagine that Hadoop would succeed the way it has. In fact, when Mike Olson first approached me when they were founding Cloudera, I was not interested. I didn't believe that folks outside of Silicon Valley would ever take Hadoop very seriously. But he, from the beginning, was like, this is going to be a billion-dollar industry. It's going to grow in this way. And everything he said has come true. He thinks the secret was getting Ann involved. And so Hadoop I created as open source because I'd been working in open source already and realized the power of open source to create standards that everyone shares and that can grow to dominate because we've got more people contributing, making them better. People are more comfortable adopting these technologies that aren't controlled by a single institution and that outlive vending companies and are really controlled by the communities that use them. I think Hadoop's in the adolescence of its life. I think it's going to be around for decades. It's the product of a community, and I want to thank everybody out there who's done their part in making this succeed. What a 10 years it's been. So yeah, I'm going to try to talk a little about the 10 years. I mean, 10 years is a long time, and it's interesting that Hadoop has become such a big deal that that attracts this big a crowd in Singapore. Certainly not something I expected when I started on this. So it's interesting to think about why is that, and I think it's really become kind of a symbol for big data, sort of a catalyst that a lot of big data has formed around, and I think big data is itself a symbol of something larger, which is the digital transformation of society, of industry, of government, of much of what we do, where computing has been growing, but I think in prior decades it was still something you could sort of position off to the side. Even with the web, it was getting at information, maybe doing some e-commerce, some media, but it wasn't really at the core of all of our institutions. And I think what we're really seeing now in this last decade has been the beginnings of an era which I call the data century, where all of our industries and institutions are going to be generating, collecting, analyzing, and driving themselves based on data. So it's a exciting time. You're probably all here because you're in this field, so congratulations. You're in a good field, I think, for the next little bit. So let's look back first. You think about what's different now than 10 years ago. 10 years ago, the hardware we used was largely pretty different to build data systems. We tended to use fairly exotic hardware rather than the sort of commodity hardware that we're able to use today. We used a different type of software. We tended to use these sort of expensive enterprise software as opposed to much more inexpensive open source software. That's been a pretty fundamental shift. Still in progress, obviously. None of these things are exact. 10 years ago, a data system mostly meant a relational database, something that you accessed with SQL exclusively. Today, not so much. SQL's still there, still a valuable player, but there's a lot of other things that are available to folks. A lot more variety in our computation. The way that we built systems was very different. We used to have to spend a lot more time up front working out our schemas so that we could transform all the data to correspond to them and then live with that schema for a decade, perhaps. And now we're able to be much more flexible about the schema that we use. And moreover, the software ecosystem was largely controlled by vendors then, by a small group of people who maybe agreed on some standards for SQL, but largely delivered that technology to us as engineers. And that I don't think is the case any longer. Much more now, the technologies are evolving organically out of the user base. And it's a very different process, and I'm going to talk some more about that. So how did we make this transition from there to here, and how much further can we take this? Is what I want to spend a little more time talking about. So let's go back and let's look at the Hadoop story as an illustration of this. But before Hadoop, I had worked for more than a decade, 15 years or so. First on largely commercial software in a number of places. I worked a lot on search engines, various other Java frameworks, Java and C++. Then I had written some software on my own time because I was worried at the time working for a web company and worried that they were going to go out of business, that the internet hype bubble was going to pop, and I wanted to have an insurance policy. So I wrote some search engine software on my own time that I owned that I could fall back on should the bubble ever pop. And I wrote this search technology called Lucene, first written in the fall of '97, winter of '98, so right in there. And then didn't do anything with it for a few years, and finally in 2000, the web bubble did pop, and I did lose my job. And then I had to decide, did I really want to try to sell this software? And I'd actually, in the intervening couple of years, licensed it twice, and I hated the process. I had to, hire a lawyer to write contracts, and then I had to figure out a pricing model, and these were just things I had no interest in doing. Nor did I want to hire people and be somebody's boss. I'd never been anyone's boss, still haven't been, for that matter. I guess I'm not manager material. So I said, what am I going to do with this? I want people to use this software. I want it to have some impact. So I thought I would try it as open source. So I put Lucene out, and slowly but surely, people started using it. And they started hiring me to help them use it, to add a feature that they would need. And I would always stipulate, whatever I add will go back into Lucene, will be open source. And proceeded this way for several years. And I really enjoyed it. It was as a developer, it was really nice to be working in public, to be able to be brutally honest with the customer. If they say, does it do this? I could say, no, not yet. We could make it do that, maybe, or maybe it will never do that. But because they weren't paying for the software, I didn't have to try to convince them it did anything that it didn't. It was what it was, and that was very refreshing. But also, I was making some income out of it. I wasn't getting rich, but I was getting paid pretty much on a monthly basis, just as I had been before working on commercial software. But the software kept getting better and better because people besides me started contributing, and it started getting to be quite big. If you look fast forward to today, Lucene is probably the most used search software out there. I supported myself for a few years. Other people have supported themselves. There's folks here from Elastic I saw who are supporting themselves to some degree based on Lucene. But moreover, it's created all this value downstream in applications that we're able to include search capabilities that wouldn't have had there not been an open source version. So it's created a lot more value because it was open source than it would have. I think if I tried to commercialize it, probably would have gone out of business. Probably no one would have ever heard of it. And so I saw that open source was not only a fun way to work and a way to work where I wouldn't lose contact with my software. I'd worked for, as I mentioned, a decade on various projects, and once I would leave a company, that software was gone from my life forever. I could never look at it again legally. Whereas the open source, I could work on it for somebody and work on it for someone else and stay in contact with it. So I much preferred this, and it had benefits for other people, but it also had great benefits for the software itself. People adopted the software much more readily. They would download it, they would try it. They didn't have to ask their boss first if they could sign a contract to evaluate it. They didn't have to do anything but try it, and then if they had a problem with it, they could, in their debugger, look straight at the source code and understand what the problem was much more easily when they had the source code right there. And some of them, not all of them, most users you hope don't have to contribute, don't have to find, fix bugs, but some of them could, and could start and keep improving it. So I think the open source really gave it this unfair advantage. And I think we tend to focus on the pricing aspect, which is an important one, the lower cost. But I think there's a lot of other characteristics that make open source more attractive for folks to adopt. This fact that it's not that they can have some control over it. That if you build on a proprietary technology and put that at the heart of your business, then part of your business is effectively owned by someone else, and your fate becomes tied with theirs. And as engineers, we always want to reduce dependencies, especially dependencies that might cause us problems. And that kind of thing can cause a lot of problems. A vendor could go out of business, could start raising their prices in a way that an open source project is going to probably be there tomorrow. And even if it's not, the software will still be there, and you'll still be able to maintain it yourself. But typically, when you've got a software project with a decent community around it, it's going to survive, and people recognize this. So anyway, come 2002 or so, I had been working in open source for a few years, enjoyed this. Folks approached me and suggested that I build a web search engine as open source. And I thought this would be a fun challenge. Probably never really not achievable, but a fun thing to try. Would be interesting. And so we started working on that. A new project called Nutch, building on Lucene, and we knew that it had to be a distributed solution. The web is bigger than one computer. Built a primitive distribution framework, basically no automation, a bunch of manual steps that you would run on a set of computers, sort of a methodology for doing things in parallel and keeping data on multiple computers. And got it running. We could run on 5 machines and download hundreds of millions of web pages, index them, analyze the link structure between them, and really realize that to get to 10 or 20 machines would be very hard. We'd have to get more people to operate them. And around that time, Google published 2 papers describing the way they were doing things internally. And they had automated these things that we were doing manually. We were effectively doing MapReduce by hand, it turned out. It was almost the identical algorithms, but automating not just the control flow, but also the reliability. As you scale up, the more computers you have, the more failures you're going to see, and the more important it becomes that if you're going to make it easily manageable, make it effectively manageable, you need to automatically handle failures. Your file system needs to be able to automatically replicate data so that if you lose a computer, you don't lose any data, and your execution engine needs to be able to recover should any processor die in the course of a computation. And Google had figured this out with fairly simple architectures that you could implement fairly easily and see that would really work. And I think before that, there's a lot of work in distributed computing, but it tended to be more complicated approaches. I think Google's real insight here was how to get the benefits of distributed computing without something that was too complicated. So we started implementing these ideas of Google's in Nutch. Within a couple of years, by 2005, had them running on 20 computers, which was as many as we could scrounge up. And it was sort of almost something that was usable, almost fulfilling this promise that I was seeing. That so Google had these techniques, and they described them to the world, and everybody said, "Wow, that would be cool to have," but I don't work at Google, so it's not really cool to me. And I realized, we could change that if we had an open source version of these. I thought, well, we can add these in Nutch, and then we'll give people this wonderful capability to, with a few lines of code, run something over petabytes of data reliably on very inexpensive hardware. It would be a game changer, a new thing for people. We weren't quite there in 2005. We'd implemented things, but we hadn't proven that it was that scalable, and we were finding there was a long tail of bugs. Even with a simple architecture, distributed computing is really hard to do well. So we needed help. A couple of us working part-time weren't going to cut it. I heard from Yahoo that they were actually very interested in having such a platform internally, and thought that what we had in Nutch would be a good starting point. So in 2006, 10 years ago, we took these parts out of Nutch, the distributed file system and MapReduce engine that we'd built there, and split them into a new project, which we called Hadoop. And you could call that the conception point. You could call the conception point back when we first started writing MapReduce in the distributed file system, or you can start it back at the beginning of Nutch. You can start it wherever you like. And so anyway, that we've declared that that when it was named Hadoop is the beginning of Hadoop.
Okay, this is all foreplay.
That's right. So that really paid off. Yahoo had thousands of nodes to run this on. They had a team of skilled engineers who could really chase down this long tail of bugs. And within a year or so, by 2007, we had achieved this promise of this technology. It now could give you very affordable processing of very large amounts of data. So to some degree, and as well, we built a community of people developing it, which made it an open source project that would likely last, that people could depend on. It wasn't just Yahoo, but there were a few independent developers, as well as folks from Facebook and LinkedIn and Twitter contributing. So to some degree, it was mission accomplished from my perspective, which is I had only ever imagined that these tools would be useful to people building search engines, maybe doing natural language research, which is something I'd done some of and understood the need for large amounts of data there. What I hadn't realized were all the other places that this might be useful. And around that time, some folks approached me and said, this could be used by mainstream industries outside of Silicon Valley. And I didn't believe that folks would ever adopt sort of open source hacker-written software in enterprises. But fortunately, the founders of Cloudera did. And they started Cloudera in 2008. A year later, I wasn't so much convinced that they were right as I was sort of ready to try something new. It's like a new crazy challenge. Great, sign me up. So I joined Cloudera in 2009, and we started helping to figure out what would it take to make this technology useful in other industries. We started working a lot on security, on connectors to relational tools, and so on, and have been at that mission since for the last 6 or 8 years now at Cloudera. The other thing that's happened, started happening very quickly. That was an interesting trend, was that it wasn't just one project. I didn't anticipate this either. That people started building other projects around Hadoop. Cloudera built some to glue things together with other enterprise technologies. But Facebook wrote Hive, so you could run SQL queries on top of Hadoop. Some folks wrote Solr, so you could run searches against data that was distributed and stored in Hadoop. And again and again adding more and more functionality to this shared core and creating this Hadoop ecosystem, which is continuing to grow tremendously fast. So we look forward to where we are. We've got a system which I think is clearly better than what we had 10 years ago. Shows a lot of real potential in pretty fundamental ways. So first, it is cheaper. The open source software is free. We have a lot of folks don't pay anyone to use Hadoop at all. It scales much further than other solutions. It's really does scale to thousands of machines, to many petabytes of data in a system quite easily and quite effectively. It's a more flexible platform. As I said, not you don't need to try to treat everything as a SQL problem. You can have machine learning problems. You can have search problems, and also have problems that mix these, that use have a machine learning algorithm which might invoke some SQL in the middle of it. Have a machine learning algorithm that builds a search system. Have an online streaming system that also is doing graph analytics and so on. That all these things can be mixed and matched to give you the right application, the right tools you need for your application, and all the time new tools coming in. So a lot more flexibility. Another big change is in the style of development that's supported. No longer do you need to spend as much time upfront doing design, because people are finding that they can afford to save data in its raw form and reprocess it, retransform it if they need to. So the people talk about a schema on read, which in many cases is actually what they do. That you leave it in the original form, and at scan time you're converting it. But more often, what you see people doing is transforming it, and then if they decide they need to change the transformation, just do it again and write a new version in the new transformation. And so all these operations become more lightweight with the combination of very inexpensive storage and inexpensive processing that makes it feasible to reprocess entire data sets easily. So we're seeing that big change, and it's a very useful change. The model of doing design work up front and fixing things doesn't build good applications. It's very hard up front to know exactly what you'll want. It turns out that it's much better to start with something simple and iterate. Try a simple version, run it for a while. Maybe you've got it fundamentally wrong, in which case you need to start over, and good thing you didn't invest too much. That's a common case. So you can try lots of simple things until you find a simple one that seems to work pretty well, and then you can improve it and measure your improvement each time around. And this is the way that we've seen again and again is the better way to build systems, and you waste far less effort. And so this this whole platform has been built with that in mind. Whereas I think prior generations were really built with much more of the waterfall engineering model in mind. The other thing I think we're starting to see is that enterprises are accepting open source software. You heard Microsoft now embracing open source, which is a wonderful example of that. But also, we see banks. The number of industries who are using this stuff is amazing. We've got customers in the intelligence community who care deeply about security, who are adopting these tools and using them in environments where they require the security to work, where they don't trust everyone who can connect to a cluster. And similarly, credit card companies who are regulated, and healthcare industries that are regulated and are required to run things in a secure manner are now comfortable using this stuff, which is incredible. And we're beginning to see this technology driving this digital transformation that I talked about at the outset. There's a lot of things that are driving the digital transformation, obviously. The fundamental thing is just the prevalence of digital devices, from watches and cell phones and cars that have processors and can communicate to sensors that we have all around us in our buildings, in our factories, in our stores. We're more and more there's a world that is generating data. Cash registers, very simple example that are now all the data that ever goes through a cash register is now available to the retailer, and they can use it. And they weren't able to effectively harness that before, and now they are harnessing it. And we're seeing this industry after industry. Banking. Banks are finding that they have all these silos that they can combine the data from and get a complete picture of their customers, of their investments, in ways that they couldn't easily before. Telcos, similarly, are able to combine things, understand not only their customers but their networks. Healthcare, we're seeing amazing developments. I talked about one in the video where Cerner is saving. They can. I don't know what the number is, but they've saved a lot of lives by using Hadoop to predict when people are likely to get sepsis, notify the hospital, and have them aggressively try to treat people before they are symptomatic. It's pretty amazing stuff that's being done. It's real, and it is really happening across industries. Now, it's still early stages. I think in the majority of big companies in the US are now using the Hadoop ecosystem, but they're using it in a small way still. There's a lot of room here to grow. And around the world, we're seeing the same thing. Lots of people are getting started, but we're at the early stages. And even once there's sort of full penetration of this technology through industry, we're not done. This platform is going to continue to evolve. We've seen this new model for how software grows and improves. No longer are vendors controlling. No longer is there any central point of control. Rather, we see people coming up with new projects, universities, companies, posting them to GitHub or Apache, and people trying them and deciding which ones are the ones that work best for them. So I think of it as a Darwinian evolution. New projects are the random mutations, and it's the survival of the fittest. And as we've seen in biology, this is a very good, reliable process to improve things. And I think we've seen the rate of evolution is incredibly fast. Only 3 years ago, probably no one in this room would have heard of Spark or Kafka. Today, they're becoming standards that we've almost everyone's heard of, and many folks are using. In another 3 years, it's hard to say what parts of the platform will be replaced, or at least augmented and improved substantially. So it's a very exciting time. I think we're going to see this rate of progress continue for a long time through our careers. I expect we'll see new things added, new improvements at a pretty good rate. It's a little bit challenging to keep up, and to some degree that's a natural limitation on the rate that the technology can change, is the rate that as a community we can absorb it and understand and make value from these the changes and consolidate. You know, it's many times I don't know how many streaming solutions there are today. I saw a list of them somewhere recently, 6 or 8 streaming platforms. Probably not all of those are going to be ones that people are using widely in 5 years. So it's hard to pick the winners now, but that will happen. There will be a winnowing down, I think, in area after area. So as we sort of look to what's going to happen in the next 10 years, I mean, I think today already the Hadoop ecosystem is the default place that people are building new data systems. You don't hear a lot about people deploying new systems using a data warehouse or a relational database as much. They tend to be thinking about for new work using the new technologies. And I think in another 10 years we'll be to the point where the majority of our installed systems are built using this new platform. I think we're rapidly approaching where not only is it the default for new things, but the incumbent, which is I think going to be a real boon. I think it's going to increase a lot of productivity in a lot of industries. Other things that I think are worth watching. The cloud technology really was born around the same time as Hadoop. I think AWS launched in 2006 as well, so 10 years ago. And cloud is also really hitting its stride right now. I think we're really starting to see widespread and large-scale adoption of cloud from a variety of vendors, not just AWS, but also Microsoft, who's hosting us here tonight. Thank you, and Google as well. It's nice to see some competition there. But we're at Cloudera, I think we're now at the point where we see 15% of our customers are deploying in the cloud. We're expecting that to rise steadily over the coming years. I doubt it will ever become so dominant that we stop having customers who want to keep things on premises. I think there are reasons why folks will always keep some things in their own data centers, whether they be costs or legal reasons. There's a variety of scenarios where people might keep doing that. And I also think it's smart for people to think about keeping their systems flexible between different cloud vendors, so that you're not completely tied and locked to one or another. Another big change we're going to see in the next 10 years is in memory systems. We see every 18 months to 2 years, I think we're going to see processors improve, hard drives get bigger. These things, as they've been doing for a long time, networking continuing to improve. But memory is probably going to start seeing 10x improvements in the next few years. We hear this from Intel. They've got new technologies coming down the pike, and as do other hardware vendors. I think we're going to see a big revolution where we're going to start having 1,000 times more memory relative to our processors and disks than we do today. And that's going to change things a lot, to have really fast access to very large amounts of data. Will drive the development of new data systems, new kinds of databases, new kinds of analytic tools, when you can not just have a petabyte that's online, but a petabyte that's accessible from any node in a cluster within a few cycles. And I think we're rapidly getting there. So that's a neat one to watch. So it's worth thinking. I'm talking primarily about technology here and the evolution of technology. But there's actually a lot of other aspects, I think, that need to change as well. I alluded a little bit to the rate that we can absorb technical changes is sort of the rate that we can understand them. But there's also a lot of other changes that are really social changes that I think we also need to be conscious of as we move forward. Open source is largely a social change in the way we produce software. This schema on read is a style issue as much as a technical issue. But moreover, I think the skills that we need to adopt and the within organizations need to change. And so I've seen many organizations unable to adopt new technical architectures because of the way their organizational structure is set up. For example, they will have one group that manages storage and another group that manages computation, and they have no way to host a system that combines storage and computation. And that's sort of a dramatic scale, but I think there's a lot of other ways in which we're starting to move towards environments that are self-serve, and that's a big change for IT. We're starting to pull decisions about systems out of IT and into the boardroom. They're becoming central to businesses, which is good and bad. It's good because this way you get the attention. It's bad because now you've got the attention. So I think that's these organizational changes are happening and need to be respected. You can't rush things too much. I think as people adopt these technologies, they need to go slowly and start with small teams and accept that their institutions will change slowly. I think it's a mistake oftentimes to try to completely overnight get a company to change the way it's doing things. There's a lot of culture in a company that you don't want to destroy. So in closing, I think Singapore is really adopting this stuff at an incredible pace. I know that Cloudera only established here maybe 2 years ago. We've seen just phenomenal growth and adoption, faster than any other region that I have seen ever in this area. There seems to be a real will to revolutionize your technology. The government, I've talked to government officials, and they seem to be very much in support of encouraging organizations. We're working on training programs with government institutions. We're going to have some announcements tomorrow about that. And I think that the Smart Nation initiative is really shows a great illustration of how Singapore is really a leader in this area. I come to a lot of places and everyone seems to think, oh, we're so far behind the U.S. in this area, and it's usually not true. People aren't as far behind as they think. What they don't realize is that everyone is just getting started. You've got, for a city this size, a country this size, putting this many people in a room, this is something real. It's not something that's tiny already. But moreover, I think the commitment and the organized coordination to attack this digital transformation is stronger here than I think I've seen anywhere else. So I think the rate of growth here is going to be that much stronger. So that's all I really wanted to say. I'm got time for I think about 10 minutes of questions left here. I'd love to hear what your concerns are, your thoughts about where things are. So thank you.
I actually do have one question. Thank you for letting me ask a question. Go ahead, clap some more. So I just actually had a very rude awakening the other day. We've been setting up some Hadoop, and been very frugal about the hardware. It's a great thing about Hadoop. You buy really inexpensive hardware, and I think we've kind of found a really sweet spot between low cost and good performance. So I'm very, very proud of the money that we save. And then I remember people come to us and say, yeah, we have to get some networking stuff. and it's going to cost you an insane amount of money. Is there, I mean, networking for Hadoop, is there a commodity standard that people have, or
I think there's standards.
Stuff that my head of is telling me.
I don't think for most people the networking hardware is more than 10-15% of the overall cost of a deployment, if that. I think most people are using top of rack switches, a switch per rack with so you've got higher connectivity within the rack, then you've got connectors between the racks as well. I think it's pretty standard architecture. There are people. Google has a much more advanced architecture, but they build their own network hardware and have written their own networking stack to run it. So not everybody can do that yet. But I don't think it should cost that much. It'd be interesting to hear what they're telling you. We've got reference configurations with all the different hardware vendors, and I think if you look down the prices, the networking is not it shouldn't be that bad. I think there is a tendency in hardware purchasing is people get excited and they want to buy the latest shiny stuff, and they tend to buy fancier hardware than they need. It sounds like you're doing a good job of fighting that and trying to be rational and find out what is the best bang you can get for your buck, which you ought to be doing.
Yeah. Okay. Yeah, I mean, it's like we've got some pretty seriously beefy servers, and the cost, once we have 200 servers in, if you amortize the cost of it, it's still like 2/3 of the cost of a server just for the networking to it.
That sounds wrong to me, but.
Okay. Good. Sounds wrong to me too.
Yes.
Why Cloudera didn't join the ODPI?
The question is, why didn't Cloudera join ODPI? We didn't see any reason to join it. We didn't see it was addressing a problem that we hear people complaining about. So we the Apache is in some sense the standards body we work with, and the Apache projects generally ensure good back compatibility, and selection of components. I think probably shouldn't be standardized. I think that stifles this innovation. Centrally standardized. In fact, we want very little centrally standardized, and so the problems that I think it's purporting it to solve aren't problems that I hear from people that they're having. Actually,
when they came out with that press release, I found it very bizarre. I mean, it's pretty much, like Pivotal and Hortonworks. It's a marketing ploy for them, in my opinion. But what I did was I took a text editor and I did search and replace for Open Data Platform, and I changed data to lunch. Okay, so it was Open Lunch Platform. It's like it's really funny. It still reads very well as an article, but it's hilarious. Once you put the word lunch in there, you realize how ridiculous it is. Everybody wants their lunch the same way. What people are looking for is consistent lunch, and it's not. I mean, everybody's got different architectures, different needs, different challenges, and one size does not fit all. But try that. Anytime you see a press release about Open Data Platform, especially replace data for lunch, it makes it much more interesting to me.
Right. Interesting. Nutch was originally named for the way that my son said lunch when he couldn't quite pronounce it. So I'm sure that's all connected. Yes.
So Hadoop can be very mind-boggling for people trying to learn it for the first time. And given that data is growing on an exponential scale, and it comes with it a lot of challenges relating to how to size your cluster, how to plan for the future scalability of to keep your organization afloat. So what advice do you have for organizations who have to do this for the first time, and given that data could be this size today, but it could be 10 times more that size tomorrow?
Yeah, I mean, I think the advice to people getting started is just to get started, to find a problem that is you think will give you some clear benefit in a relatively short amount of time. And I think people oftentimes spend too much time, they're in the habit of worrying and planning rather than saying, here's some data that we have, here's a problem we think it could solve, let's see what tools we can use to solve that, and getting their hands dirty, and that's the best way to learn how to build these systems, which tools are appropriate, how to manage the data, and then as you add the second system, and that said, there's a lot of tools and a lot of advice you can get about best practices, and you certainly ought to read those in the process, but there's no substitute for working on a problem that you care about, and so I always think that's the best way to get started. Does that make sense? Yeah.
What's the most surprising thing you've learned growing a community around open source software?
What's the most surprising thing? It's, I don't know if there's, if I can answer that directly. It's work to build a community. You have to be very, very consciously interested in doing that. I think the reason I've been reasonably good at building communities is I'm lazy, and I want to try to get other people to do the work instead. And so I always try to turn every request into try to get someone else to become a contributor, so that I don't have to do it, and put myself out of a job. That's always my success criteria for an open source project is when I don't have to be there every day, responding to questions and helping things along. But I don't know if that's a surprise. I tend to not be a person who has a lot of expectations, and or a grand vision. Much more reactive than proactive about things like this. And so, seeing opportunities and pursuing them, and if they succeed, that's great. And if they don't, try something else. So I think I've been surprised just at how effective open source is. I think that the biggest surprise is just that. I had no expectation. It was just an experiment, and that has vastly exceeded my expectations. Biggest surprise. I didn't expect Hadoop to be this useful. That was a surprise. I thought it would be somewhat useful, and I think taking that leap of faith that others would come and help, that if I did some work for free, that something good would come of it, was probably the secret more than anything, and the surprising thing is it worked. So, yeah.
In spite of the phenomenal success of Hadoop, it still cannot do many things what RDBMS can do. What is the potential of Hadoop taking the space out of RDB?
Yeah, no, it's a good question. So why isn't there OLTP in Hadoop? Is that another way of saying it?
Yeah.
And I think the fundamental reason is OLTP and the relational database is a very mature technology, and to go up against it would be very difficult. There's a lot of features that have been developed over decades. Moreover, because it's a largely solved problem, the demand for an open source, more scalable OLTP engine isn't really there. The sorts of data that people are doing transactions over tends not to be that large. If you think about the sort of multi-table coordinated transactions. The sort of data that they're having trouble managing is data from logs, data from sensors, sort of IoT data, these sorts of things, which isn't transactional. It's time series. It's big messy stuff, and so that's where the need was greatest, and the ability to build something fairly simple, as Hadoop was initially, and still find a lot of value. It was there, Whereas if you tried to build a slightly better OLTP system, it would have been a much tougher battle to win. I think long term, we're seeing more and more transactional capabilities added to the Hadoop stack. There's outright OLTP engines like Trifodian. That's a Apache Trifodian built on top of HBase. And I think there's another Apache project that's also, I'm blanking on the name right now, adding transaction support. So it's coming. People are doing that. There's also, a lot of people I think are finding that for, say time series data, even then, you may not want to just treat it as a file that you append to. That you might want to do updates. That there are times when that you find the clocks are set wrong on some set of machines, and you need to rewrite part of the data set, and it's much easier to do that if you have a read-write store. And so HBase works for a lot of applications. Kudu is a new component that's been being added there to support high bandwidth of updates at the same time as high performance on queries. So I think we're approaching OLTP, and I think there's a lot of cases that are sort of somewhere between OLTP and your sort of Hadoop batch processing that are of interest too. So.
What will be your next challenge?
My next challenge? Getting enough sleep. No, I in the last year or so, I've stopped coding much and sort of taken on the mission of trying to be an ambassador for this technology platform. I think that's what's needed. I think that's where I'm. I would write code when I thought there was something that no one else would do, and that I needed to go do so that it could exist. And now I don't have any ideas of things that somebody else isn't going to do. There's so many people out there who are trying different things that I don't think I can be the first guy there with any of these things any longer. Maybe that's just I'm getting old, which I am. But so mostly what I'm doing is my challenge is trying to communicate with people about this as we're doing tonight. So, yeah.
So our customers are not buying Hadoop anymore; they are buying use case. So according
yes.
to you, what are the top 3 use cases you're seeing, like when you're visiting customers or public sector organization or partners?
Sure. So it depends on how you want to define use case. We talk about industry-specific, actual use cases, which it's hard to come up with the top 3. I would characterize some of the classic uses are, combining multiple sources of data to give you a deeper view. Sort of maybe some bread and butter use cases for us are ones that I think I mentioned earlier. When we come to a region like Singapore, we see banks that want to do look at fraud and also look at maybe anti-money laundering and look at risk, understand their exposure to risk. So those are very common use cases again and again, and there are a lot of banks in the world that need to address these issues. And they each want to sort of have a slightly different approach to it. It's not a total cookie cutter kind of a thing. Telcos similar. They have they want to understand a lot of marketing. They want to understand churn, wire customer switching. They want to improve their networks. So again, these are popular first use cases in big industries that are repeated around the world. What other? So those are the sort of primary ones. There's a lot of cases where it's just people cost cutting, want to be able to process more data than they can afford to at a lower cost, and there's a number of different variations on that where they're either able to get more quality, find things they weren't because they're analyzing more stuff, as well as just directly cutting costs. So. Yes.
Do you think the ICJ will be using Hadoop?
Do I think the
ICJ,
ICJ?
Yeah.
What is ICJ? Sorry.
the International Consortium of Journalists, for the recent Panama hearings?
Oh, for they use Solar. They use Lucene and Solar for the Panama Papers. They used a lot of open source tools. They had 11,000 documents, and they indexed all of those. They used Apache Tika, so they used a lot of open source tools. I don't think they use Hadoop, to my knowledge.
Yes,
But
I'm curious whether they will come to Hadoop.
are
Are you going to preach to them so they can get results fast?
No, I saw an article today, and they talked about there was a new phrase they used. It was a big something about this is a new trend in having big leaks of data. That's not the phrase they used. And that's
Yeah, that's right. Last night, I think Bloomberg said that. It was a... Yes, I
So I think we will see more of that, and I think open source really enables that. Enables folks to who wouldn't have otherwise probably acquired a system to investigate something like that. Probably wouldn't have the budget to now using open source tools really find patterns in data sets like that they wouldn't have otherwise. Let me go over this side. Sure, here.
Just wanted to know your thoughts about Mesos and Yarn.
We at Cloudera we primarily support Yarn. That's what seems to work best for our customers who are mostly running the Hadoop stack, and I think it's slightly more mature. But I think it's one of these cases where if enough people start getting value from Mesos, then we might end up adding support for it. So it's a great example of I think a very healthy competition but between schedulers.
Do you think they're actually going to diverge, I guess, in the future, where how they'll be developed, or is it? I guess at the moment they're competing, but how do you see them?
Yeah, I mean, I think you could probably nest one within the other either way. You could probably run Mesos on Yarn and Yarn on Mesos if you really wanted. People tend to pick one or the other today. I think Mesos is better at supporting non-Hadoop ecosystem workloads, integrating those. And I think Yarn does a better job of integrating different Hadoop ecosystem workloads. So they have different strengths. So it sort of depends on what you're doing, is my understanding. Yeah.
So a lot of open source technologies and frameworks keep coming up, right? So, for example, like Apache Spark, they basically promote that they are faster than MapReduce. Right, in batch processing. I was reading about Cassandra. They talk about they have Cassandra file system which can replace HDFS. Right. So, where do you see Hadoop 5 years down the line, or like there are competitions?
I mean, we'll see which things catch on. I mean, I'd frankly be surprised if people are replacing HDFS with Cassandra FS. I haven't heard of anybody doing that. I know they have that out there, and I think it's used in a few edge cases. It's useful.
Promoted as part of Cassandra analytical systems.
But I mean, that's for the market to decide. If people start finding that's very valuable, then they'll start using that. I think HDFS has done a good job so far of keeping up and staying relevant. MapR has given HDFS a lot of competition, which HDFS has responded to and improved. Kudu is a new storage engine, very different than HDFS, which we're optimistic about that people will find useful. But there's a lot of other distributed file systems out there that haven't caught on that much. So we'll see. I don't make predictions about that because it's not mine to choose. There's a complicated calculation for what people are comfortable adopting, especially at the storage layer. Yeah.
So you talked about big data is trying to catch up with what RDBMS is doing, like OLTP systems trying to have all the characteristics of OLTP. So is the RDBMS system is also trying to leverage any of the Hadoop system or big data kind of thing in the underlying, like the application stays same while the underlying storage or the processing they change it to leverage the new technology?
Yeah, I haven't seen any compelling uses where somebody was able to make Hadoop live under a traditional RDBMS. I think there are people who try to do that. It tends not to perform well, tends not to take good advantage of Hadoop and its properties. It's possible to hook anything together, but I don't think that the Hadoop ecosystem is explicitly trying to catch up with the relational world. I think largely the bulk of the success in the Hadoop ecosystem is in problems that you could never begin to try with a traditional RDBMS. That still remains the sweet spot for this technology. There are some things where people are building OLTP engines that live within the Hadoop ecosystem, and those may start to replace traditional RDBMSs. But so far, I really think that the bulk of things are relatively disjoint. But it's also where the bulk of innovation and investment is in organizations. There aren't that, I don't see that many new transactional applications being deployed, so much as analytical applications. It seems to be where people are more interested in these days. So, in the back.
Now that the memory, this is going to be a difficult question. Now that the memory becomes cheap, and Apache Spark and Sync are actually running on Yarn itself, and do you think there is still relevance for IO-based staging like MapReduce compared to what the graph itself gave Spark?
Yeah, so it's a good question. I suspect so. I think there's always, one of the things that surprised me through the years is the degree to which people keep putting more and more disks per node. The ratio of disks to cores seems to be have grown considerably, and I just attribute that to the fact that people like to have lots of data around. They like to not throw things away, and so I think what the new memory technologies let us do is have a much larger working set. But I think it's still going to be more expensive than spinning Rust, as they say. And so people will still, if you want to really keep a lot of data online, have a lot of hard drives. Is my suspicion. So I think it'll be a long time before we see fully solid state clusters. I think there's a real attraction, and it's, I think, even in the most optimistic scenarios, it's going to remain 10x cheaper per byte, which is significant. So sure.
Is there any memory processing?
Any memory processing technologies? So Kudu was designed with this new memory architectures in mind. We've got so Intel's new memory technology is called 3D Crosspoint, and we've had early versions of that in-house at Cloudera for over a year, and knew about the designs of it before that because of our partnership with Intel, and have been testing it and making sure that it works well. So Kudu is definitely designed to take advantage of that. I mean, one of the things that changes when you've got lots of fast memory is that CPU can easily become your bottleneck rather than I/O. So they've focused a lot on the data structures they use. So for example, you probably don't want to compress data in memory. You want to have data structures which you can easily traverse very rapidly, and so that changes how you do things when I/O is not a bottleneck. And so Kudu's been designed with that in mind, and I think a lot of existing technologies probably haven't been, and that's because it's a new design. Is able to do that. So that's one. Yes.
So there are different file systems as such, like not about distributed file system, but apart from distributed file system like NFS, or you have your data in SFTP and all these things. So I've seen like in Apache community there is some movement in designing a file system called HDFS, which is Hadoop compatible file systems. So like in general, how does this kind of like integrating different file systems other than DFS will work along with in the Hadoop ecosystem?
Well, within Hadoop, I mean, there's an API, which is effectively I think it's called the File System API. I think I wrote it about 10 years ago, or maybe 12 or 15. And so that is a standard for interoperability. You know, there are lots of different implementations of it. I think we're going to start to see more file system, better support for block storage systems in that cloud providers give, so that people can more efficiently access data, say that's in S3, without having to move it into HDFS to make that a first-class citizen. But I think there's they're pretty good. I mean, there is a standard API for that today, and I think there are even some compatibility tests and documentation around that. I'm not sure whether what more is required for compatibility.
No, I mean, instead of accessing directly through APIs of these file systems, why not have an integrated layer for the HDFS and all the other file systems? I think there is some work going on in the Apache community called HDFS, if I'm not wrong, Hadoop compatible file systems.
I've seen that used to talk about I thought the API more and the specification of the behavior of implementations of that API is what I'm familiar with that. But maybe there's something, maybe there's a layer as well. If there isn't, great project to start.
I have a second question.
I don't know if we get second questions, so I think we're running tight on time. I'm gonna get this guy in the back here. Yes.
It's not a technology question.
Okay.
Who's your first teacher and who taught you programming?
Who's?
What's your first program? Which language?
My best teacher? Boy, I had a lot of good teachers through the years. What's that? First teacher? I mean, go back to elementary school. My second grade teacher was wonderful. My fifth grade teacher just died this year. He was my neighbor. It was very sad. He was wonderful. He taught me a lot about science, and that I still know. So it's so many teachers. It's hard to pick one. There were no computers in my high school. I didn't use a computer till I was in college. As a freshman, the only sort of introductory programming courses were in Pascal. That was the first language I learned. My second year, I took a Lisp course and didn't care for it much, but I ended up by my third and fourth year in college becoming a Lisp programmer, and spent 6 or 8 years where that was my predominant programming language. And I also I really enjoyed one of my best teachers for programming was actually assembly language. We had a wonderful teacher who really believed in assembly language that was really had a lot of style. He was passionate about the quality of your assembly language. So that was fun to have somebody who could make you care about that, making very readable assembly language. So I enjoyed that too.
Some of the traditional cluster file systems have attempted Hadoop compatibility like GPFS, GFS, and some of the others. Do you see them getting anywhere in terms of production?
To get somewhere, they just have to be, get popular, and they have to perform well. You have to. People are risk averse, particularly when it comes to file systems that store their data. So I think there's a big hurdle to overcome. If people trust HDFS for the most part, HDFS has a good track record of not losing data, and it has a certain performance benchmark. And so in order to replace it, I think you have to be substantially better. You have to have some big measurable advantage. Either much higher performance, very different access pattern, or something like that. I think just being a slightly better file system is probably not enough to get people to move off, would be my guess. But we'll see. Last question. Where is it? Not you, over here.
Thank you. Do you think Cloudera are getting into solutions? So Oracle, SAPs, and all of them are providing solutions rather than just platforms and solutions. Whereas Cloudera is still only providing a platform. So somebody does implement it well enough, but most people don't get that or are not implementing. So do you think Cloudera is going to move from the platform to the solution space?
No, I don't think Cloudera is going to become a solution company anytime soon. We're very interested in being a horizontal play. We think that's the best way to help this market grow. I think once you start doing solutions, you start competing with your partners. And rather, we're very aggressive about trying to work with partners. We find again and again the customers we're successful with are those where we're bringing in lots of partners who can help to build the complete solution. Hardware partners, visualization partners, contracting partners, and so on, and try to never do it alone. And I think that's our plan for the long term. I think if you look 10 years out, then I think we could start looking at solutions. But I think that's a good ways away.
Okay, so that was the last question.
Yep.
Well, almost the last question.
Uh-oh.
Come on. We're gonna cut the Hadoop. Happy birthday. No.
Oh, we're over time here.
So what's the dumbest thing you've ever seen a person try to do with Hadoop? Like the dumbest use case. It's like, why?
I don't keep a list of dumbest things I've ever seen. I don't think.
All right. So.
No, you haven't.
Okay, so this is Hadoop's 10th birthday. So we're going to do a ceremonial cake cutting, and then I don't know what. I guess you're going to go home, right?
You're going to have a cake fight?
Yeah. Okay. I'm dressed for it. You're not. All right. So I don't know. How do you do a ceremonial cake cutting to celebrate it?
We sing happy birthday.
Sing happy birthday.
We sing happy birthday.
We have to all sing.
Hadoopy birthday
to you.
Hadoopy birthday to you.
Hadoopy birthday to birthday. Hadoopy birthday to you. Woo!
Yay! All right. So let's come on.
You want to do There we go.
All right. Who wants the first slice?
Should we? Is that too big? We're not going to make it very many. We're not going to get 100 slices out of it.
Yeah. Well, no, we're not going to. That's why they had cupcakes. So.
All right.
All right. So afterwards, come on up here. Have a slice of nice slice of Hadoop. Okay. Doug, thank you very much for coming.
Thank you.
Appreciate it.
Pleasure.
All right.
Thank you all for coming. Thank you.